All right, here we go. The objectives today. Students will be able to change a quadratic function from general form to vertex form by completing the square when the leading coefficient is 1. Let's real quickly write down general form is y equals ax squared plus bx plus c. All right, the completing the square technique is used to convert or change a quadratic function from general form to vertex form. There are two cases, and today we're going to do case 1 when a is 1, and tomorrow we're going to do when a isn't 1. So we're going to start with something simpler today. So here we go. I have y equals x squared plus 2x minus 4. So do you see that a is 1? Everybody see that? A is 1. So first, group all the terms that have x's and place them in a parenthesis. So I'm giving you a nice sample, and then we're going to do 2 together. So you group x squared and 2x. Then you're going to divide the coefficient of x, not the coefficient of x squared, the coefficient of x. So I take 2 and I divide by 1, and then you square it. And then you add that. Well, you can't randomly add, so do you see I've added it on the inside parenthesis and subtracted it. So that is a net of 0. Okay, I added 1 inside the parenthesis, subtracted. Then, so now you can see the method to the madness with my warm-up. X squared plus 2x plus 1 factors into x plus 1 times x plus 1, which is x plus 1 squared. Okay? So now the vertex, what is the vertex? -1, -5. All right, so I think the hardest part is right here. Let's pause here a moment. So note, x squared plus 2x plus 1 factors into x plus 1, the quantity squared. So write this down, because when you look back through your notes and you're like, okay, what did we do? Why did we do it? How did we do that? This is going to be the hardest part until we get comfortable with the factor part. So this is why I had you practice this the last 2 nights, is that this is the first term squared. X times 1 doubled is 2x, 1 squared. Okay, and it has a special name. It's called a perfect square trinomial. All right, so here we go now. So we're going to start with x squared, y equals x squared minus 4x minus 4. So we're going to look at the steps above. Step 1, put the x squared and x together in a parenthesis. Now you're going to take half of the x value, which is -2, and square it. -2 times -2 is +4. Well, if I'm adding 4, I have to balance the equation and subtract the 4. Now, how does x squared minus 4x plus 4? The purpose is to write it as a quantity squared. Anybody feel comfortable? What is that? Humira, what is that? X minus 2 squared. So do you know it's always going to be the half number? It'll always be the half number if you're a little confused. So now this one is going to open up. My vertex is 2, -8. The axis of symmetry is x equals 2. To find the y-intercept, let x equal 0 in the original equation because it's easier there. So what's the y-intercept? Yeah, Brennan.
Y equals -4.
Good job. Y equals -4. And if I'd like to put it as an ordered pair, I can say 0, -4. So let's start working this. Let's plot 2, -8, 0, -4. What's the symmetrical point? You just had a quiz on this yesterday. So what's my symmetrical point? Yeah, Brendan. 4 minus 4. The domain is -infinity to infinity. The range is -4. Oops, sorry, kidding. -8. Kidding. -8 to infinity. Now, the y-intercepts. This is going to be a little bit tricky. And I'm really planting seeds for something else. To find the x-intercept, let y equal 0. So I'm going to do this one from the vertex form. And again, I'm trying to review something from Algebra 1 where it was called the square root property. So you're going to add 8 to both sides. Excuse me. And we did this earlier in semester 1. Then do you remember? You do plus or minus the square root of 8 equals x minus 2. And x is 2 plus or minus, and then I'm going to simplify. The square root of 8 is 4 times 2. Again, square root 8 is 4 times 2, so that's 2 square root 2. So really, you'd need a calculator to figure out where those are, but at least I can, in fact, find them exactly. Again, to find an x-intercept, we know that we let y equal 0. Vertex form is easier. On Tuesday and Wednesday next week, we're going to do quadratic formula. Did you remember that from Algebra 1? We did a little bit 2 years ago. So you would do quadratic formula from general form, or I think it's easier to do from the vertex form. All right, questions so far? It's not too bad. All right, let's look at example 2. Complete the square to convert the function y equals x squared plus 6x plus 2 to vertex form. So here we go. Step 1 is group the x terms together. The next step, take half of the coefficient of x. That's not x squared, but the coefficient of x. So half of 6 is 3, and I square it. So I'm going to add 9 inside the parenthesis, and I subtract 9 outside because I have to have a net effect of 0. All right, so how do I write x squared plus 6x plus 9? How can I rewrite that, Nick?
X plus 3 squared.
Awesome. X plus 3 squared minus 7. Now, one of the most common questions I receive is students say, what happened to the 6x? The 6x is in here. It's x squared plus x times 3 doubled is 6x plus 3 squared. X plus 3 squared is the factored form of x squared plus 6x plus 9. It is there. All right, I'm going to pause a moment and give you maybe 2 minutes, and you get as much filled in as you can before I start going. All right, so this one opens up. My vertex is -3, -7. My axis of symmetry is x equals -3. My y-intercept is 0, 2. What's the symmetrical point on this one? Yeah, Brennan?
-6, 2.
Good job. -6, 2. The domain is -infinity to infinity. The range is going to be -7 to infinity. To find an x-intercept, I'm going to let y be 0 and use the vertex form. Okay, this will be easier. And we haven't reviewed yet this year quadratic formula. So I'm going to add 7 to both sides and then do plus or minus the square root 7. Okay, when I have something squared, remember when we did some exponent properties, something squared, it's plus or minus square root, and then I subtract the 3. So even though I can't really tell where those are without a calculator, those are the x-intercepts exactly. And don't forget to actually sketch the parabola. All right, so let's do a quick summarizing, okay? Let's summarize what we just did today. General form is y equals ax squared plus bx plus c. Vertex form was y equals a, the quantity, x minus h squared plus k. Okay, so today we talked about general form and vertex form. The new concept is completing the square allows us to convert general form to vertex form. So we started with what we knew, general form and vertex form, and this led us to something new, completing the square. One more thing I'd like you to write down just so you have a nice location for it. It's not new. You've been doing x and y-intercepts since Algebra 1. But to find a y-intercept, you let x equal 0. To find an x-intercept, you let y equal 0.